The night sky holds secrets older than history itself. We are about to explore 25 unexplained cases of ancient astronomical knowledge, instances where our ancestors demonstrated an understanding of the cosmos that still baffles experts today. By the end, you will see a pattern emerge that challenges our entire timeline of human discovery. How did a 2,000-year-old Greek device predict eclipses with clockwork precision? And why do myths from across the globe describe celestial disasters with shocking accuracy? What does it truly mean to look up and wonder? This single object, pulled from the seafloor over a century ago, remains the most confounding artifact in the history of science. It is the Antikythera Mechanism, a lump of corroded bronze and wood recovered from an ancient shipwreck off the coast of Greece. At first glance, it looked like little more than a rock encrusted with marine life. But inside that calcified shell, researchers found a complex clockwork universe, delicate interlocking gears, precisely marked dials, and inscriptions that spoke of celestial cycles. This was not a simple navigational tool. It was a mechanical computer built around 100 years before the Common Era, designed to model the heavens. The genius of this device is almost beyond belief. By turning a hand crank, an operator could advance the mechanism through time. On its front face, pointers would show the ever-changing positions of the sun, the moon, and likely the 5 planets known to the ancient Greeks. Another dial tracked the lunar phase, displaying a beautiful, rotating silver and black ball to mirror the moon in the sky. Most astonishingly, a sophisticated subsystem of tiny gears could predict eclipses, not just when they would occur, but their characteristics, whether they would be lunar or solar, and even the color and direction of the shadow based on ancient Babylonian cycle patterns. This was not guesswork, it was precise mathematical astronomy cast in bronze. The historical context makes its existence even more jarring. This mechanism was not a one-off miracle. Inscriptions on its casing suggest it was an instructional device, possibly from a school of philosophy or a wealthy patron's collection. It represents a peak of technological and astronomical understanding in the Hellenistic world that we simply did not know existed. And then it vanishes. The knowledge required to build such a device, the intricate understanding of gear ratios and celestial cycles, was utterly lost. For over 1,500 years, nothing of comparable mechanical complexity would appear in Europe. The technological and intellectual gap is a chasm. How could something so advanced be created, used, and then completely forgotten, leaving no trace in the historical record until a chance discovery in the deep? The Antikythera Mechanism stands as a silent, ticking rebuke to our linear view of progress, a ghost from a past that was far more sophisticated than we ever dared to imagine. While the Greeks built their cosmos in bronze, the Egyptians painted theirs in stone. High above the sands, inside the temple of Hathor at Dendera, lies a masterpiece that has ignited a fierce debate for centuries. Carved across a massive sandstone ceiling is the Dendera Zodiac, a breathtaking bas-relief map of the night sky. Here, the familiar figures of our zodiac, Taurus the bull, Leo the lion, and Virgo the maiden, are depicted not as abstract symbols but as vibrant, detailed gods and goddesses sailing in celestial boats. It is a stunning artistic achievement, a snapshot of the heavens frozen in time. Officially, the temple dates to the late Ptolemaic period, around the 1st century before the Common Era. This aligns with the known history of the site's construction. But the moment you look closer at the celestial clockwork etched into that stone, questions begin to multiply. The arrangement is not a simple decoration. The constellations are positioned with deliberate, specific relationships to one another. The 5 known planets are shown in precise locations relative to the ecliptic, the sun's path across the sky. This level of detail suggests it was meant to represent an actual astronomical configuration, a specific date and time, and that is where the mystery truly begins. When researchers attempted to calculate the date encoded in the star map, some arrived at a shocking conclusion. Based on the slow, grand wobble of Earth's axis, a cycle known as the precession of the equinoxes, the positions of the constellations in the Dendera zodiac seem to match the sky not from 2,000 years ago, but from a time much further back, perhaps as early as 9,000 years before the Common Era. Precession is an incredibly slow cycle, taking nearly 26,000 years to complete. For the ancient Egyptians to have understood and recorded its effects, they would need to have been observing and meticulously documenting the stars for millennia, passing that knowledge down through generations of priest astronomers. The mainstream view argues the zodiac is simply a symbolic representation from the 1st century, influenced by Greek and Babylonian astronomy, yet the precision is haunting. Could the Dendera zodiac be a later copy of a far older celestial map, a sacred diagram preserving knowledge from a forgotten epoch of Egyptian history, a time when the stars themselves were in a different house? This stone ceiling does not just depict the sky, it asks us how long humanity has truly been watching it. From the grand stone ceilings of Egypt, we travel to a forested hill in central Germany, where a discovery would rewrite our understanding of the Bronze Age mind. It was 1999, and treasure hunters using metal detectors unearthed a bizarre object buried on the summit of the Mittelberg Hill. What they found was the Nebra sky disk, a stunning bronze disk about the size of a dinner plate, inlaid with gold symbols that shimmered against a blue-green patina. Dated to around 1,600 years before the Common Era, this artifact is not merely old, it is a conceptual leap. It is, without dispute, the oldest known realistic representation of the cosmos anywhere in the world. The gold inlays are not random. A large circle and a crescent clearly depict the sun and the moon. Scattered across the field are 32 smaller stars and one cluster of 7 stars grouped tightly together. This is a precise depiction of the Pleiades, the famous star cluster known across countless ancient cultures. But the disk reveals even more sophisticated thought. Later, 2 golden arcs were added along the edges. These arcs mark the solstice sunrises and sunsets, the extreme points on the horizon where the sun would appear and disappear throughout the year. This transforms the disk from a simple picture into a functional instrument. Scholars believe it was a complex calculator, a physical model used to harmonize the conflicting rhythms of the sun and the moon. The solar calendar governs our seasons and is essential for knowing when to plant and harvest. The lunar calendar, based on the phases of the moon, is simpler to track but drifts out of sync with the solar year. The Nebra sky disk, with its sun, moon, and Pleiades cluster, provided a visual key. The Pleiades disappear and reappear in the night sky in a yearly cycle that aligns with the agricultural seasons. By observing when the crescent moon passed near the Pleiades on the disk, Bronze Age astronomers could determine when to add an extra lunar month, a leap month, to keep their lunar calendar in step with the solar year and the crucial rhythm of the farming world. This means that over 3,600 years ago, people in the heart of Europe were not just stargazing, they were doing advanced practical astronomy. They were encoding a sophisticated understanding of celestial cycles into a portable metal object, creating a tool to bridge heaven and earth. This disk predates any written records in the region by centuries. It whispers of a shared pan-European astronomical tradition, a language of the sky understood from the British Isles to the Alps long before history decided to write it down. That understanding of celestial rhythm was not confined to the ancient Old World. Far across the Atlantic, in the dense jungles of Mesoamerica, another civilization was watching the same stars and achieving a level of precision that remained staggering. The Maya were not just astronomers, they were cosmic accountants, and their greatest ledger may be the Venus tables of the Dresden Codex. This bark paper book, one of the few pre-Columbian Maya texts to survive the Spanish conquest, is a masterpiece of mathematical astronomy. Within its painted pages are detailed charts that track the complex movements of Venus with an accuracy that seems almost impossible for a culture without telescopes. The Maya saw Venus not as a simple planet but as a powerful, dualistic god. It was the morning star, a harbinger of war and conflict, and the evening star, a symbol of renewal. Its cycle is intricate. From our earthly perspective, Venus takes about 584 days to complete one full cycle of appearances, disappearing behind the sun, then re-emerging first as the evening star, then vanishing again before rising as the morning star. The Maya didn't just know this approximate number, they mastered its every nuance. Their tables in the Dresden Codex account for the slight irregularities in this cycle over vast periods of time. They could predict Venus's first appearance as the morning star after its period of invisibility, and they synchronized this celestial rhythm with their own sacred 260-day calendar, the Tzolk'in, and the 365-day solar year, the Hab. This was a monumental feat of long-term observation and calculation, but the purpose of this knowledge was deeply woven into the fabric of Maya life, particularly warfare. Kings and priests would consult these tables to time military campaigns and ritual battles, to launch an attack when Venus, the great celestial warrior, rose brightly in the dawn sky was to align human ambition with divine will. It was believed to bring power and favor from the gods. The mathematical sophistication here is profound. The Maya used a base 20-number system and had a concept of zero, allowing them to perform the complex calculations needed to project Venus's position forward and backward in time for centuries. They corrected for the drift between their calendar and the actual astronomical cycles with a precision that rivals modern computations, and this forces us to ask a difficult question. How did they do it without lenses to magnify the sky, without precise clocks? They achieved this through generations of relentless, naked-eye observation. Priest astronomers would have spent lifetimes watching the horizon, noting the exact days of Venus's disappearances and reappearances, painstakingly recording this data on codices now lost to time. The Dresden Codex is likely just a surviving summary of a much deeper, older tradition. It is a testament to a civilization that saw time itself as a sacred, measurable force, and the planets as actors in a grand, predictable drama written across the heavens. Such precise celestial tracking demands a stable platform, a monument to anchor the heavens themselves, and no structure on Earth embodies this ambition more completely than the Great Pyramid of Giza. Its perfection is not just in scale, but in its impossible alignment. Each of its four massive sides is oriented almost perfectly to the cardinal directions: north, south, east, and west. The deviation is astoundingly slight, an error of less than 1/15th of a single degree. To put that in perspective, that is a margin finer than the thickness of a coin held at arm's length. For a structure built over 4,500 years ago with blocks weighing multiple tons, this accuracy is not a happy accident. It is a statement of intent. How could the ancient builders achieve such precision? The most compelling theory points to the stars, specifically the circumpolar stars that never set below the horizon. Ancient astronomers could have used a simple instrument, perhaps a vertical rod or a sighting tube, to track the arc of a single star as it circled the celestial pole. By marking the extreme points of its path, east and west, and bisecting that angle, they could find true north with remarkable accuracy. This method requires patience and repeated observation over many nights, but it is elegantly simple and devastatingly effective. It turns the entire sky into a giant, rotating clock face with the pyramid's base as its fixed hand. Yet the celestial connections run deeper than the foundation. Within the pyramid's heart, the so-called air shafts emanating from the king's chamber have fueled one of archaeology's most enduring debates. These narrow, claustrophobic corridors were long thought to be ventilation shafts, but their precise angles tell a different story. One pair of shafts points northward, not toward the open air, but directly at the circumpolar stars, the eternal, undying stars the Egyptians associated with the soul of the pharaoh. The southern shafts are even more provocative. One targets the belt of the constellation Orion, which the Egyptians linked to Osiris, the god of rebirth and the afterlife. The other points toward Sirius, the brightest star in the sky, whose heliacal rising, its first appearance before dawn, signaled the annual flooding of the Nile and the promise of renewal. Critics argue that the shifting sky due to precession means these alignments were only perfect at one specific moment in time, around 2,500 years before the Common Era, coinciding with the pyramid's accepted construction date. This is the core of the mystery. Were these shafts simply spiritual conduits for the king's soul to ascend to the stars, or were they also sophisticated sighting tubes used during construction to align the monument with specific cosmic markers? The Great Pyramid stands as a silent argument that its builders saw their work not just as a tomb, but as a machine built for eternity, its geometry permanently locked into the turning gears of the cosmos. But to truly grasp the ambition of ancient sky watchers, we must consider the scale of their patience. While the pyramids point to the stars, another monument captures the very heartbeat of the sky across generations. On the windswept Salisbury Plain in England, the great stone circles of Stonehenge stand as a silent testament to a civilization obsessed with celestial time. Most know it aligns with the summer solstice sunrise, a single day of the year when light pierces the heart of the monument. Yet this is merely the opening chapter of a far more complex story. Stonehenge was not a simple calendar, it was a sophisticated astronomical observatory, engineered to track cycles that stretch beyond a human lifetime. The first clue lies in a ring of 56 mysterious pits encircling the monument, known as the Aubrey Holes. For decades, their purpose was unclear. Then, a revolutionary theory emerged. Researchers proposed that these holes were not just ritual pits, but part of a colossal counting machine. By moving markers, perhaps stones or posts, from hole to hole year after year, the builders could have tracked the intricate dance of the sun and moon to predict eclipses. This relies on a cycle called the Saros cycle, a period of approximately 18 years and 11 days after which the sun, earth, and moon return to nearly the same relative geometry, and a similar eclipse will occur. 56 years is a triple Saros cycle, a period that would bring the eclipse pattern back to the same season. This suggests the builders of Stonehenge understood celestial patterns so long and so subtle that maintaining this knowledge required meticulous record-keeping across multiple generations. It transforms the site from a static temple into a dynamic computer, its logic etched into the earth itself, but the lunar connections grow even deeper. Look beyond the famous central stones to 4 outliers known as the station stones. Only 2 of these survive today, but their positions create a perfect rectangle. The long sides of this rectangle point to the most extreme rising and setting points of the moon, not in its monthly cycle but in a far grander one. Every 18.6 years, the moon reaches a point called a major lunar standstill. At this time, the moon's path across the sky reaches its maximum northern and southern limits, rising and setting at points on the horizon it will not touch again for another generation. The station stone rectangle aligns precisely to these extreme points. To encode this 18.6-year cycle into stone means the builders observed the moon's subtle drift along the horizon for decades, perhaps for a century, noting its slow creep to a climax that most people would never live to see twice. This was a project of breathtaking long-term vision. Stonehenge then becomes more than a monument. It is a multi-generational library of stone, built by people who dedicated their lives and the lives of their children and grandchildren to a single goal, understanding the rhythms of the cosmos and making them permanent. They built for a future they would never see, trusting that the stones would keep their celestial knowledge alive. the patience of Stonehenge finds a breathtaking echo on the other side of the Atlantic, carved not into standing stones but into the living rock of a desert canyon. High atop Fajada, but in New Mexico's Choco Canyon, a secret solar clock has been ticking for nearly 1,000 years. Here, the ancestral Puebloan people engineered a phenomenon of light and shadow so precise it feels like magic. On a south-facing cliff wall, they carved two large spiral petroglyphs, elegant coils etched into the sandstone. Then, with astonishing foresight, they positioned three massive, wedge-shaped stone slabs to lean against the cliff just so. These slabs are the genius of the design. They do not block the sun, they sculpt it. Throughout the year, narrow slivers of sunlight filter through the cracks between these giant stones. These beams crawl across the rock face like celestial pointers, but on only 2 days does their performance reach perfection. At midday on the summer solstice, the longest day of the year, a single dagger of brilliant light pierces the center of the larger spiral, perfectly bisecting it from top to bottom. It is a moment of stunning alignment, a beam of light acknowledging the sun's peak power. 6 months later, on the winter solstice, the shortest day, the display changes. Now 2 distinct daggers of light appear, framing the same spiral on either side, as if holding the symbol in a bracket of sunlight. This is not a vague, symbolic gesture. It is a precise, repeatable astronomical instrument. The positioning of those 3 multi-ton slabs was a deliberate act of engineering. A shift of just an inch or a change in the angle of a single slab by a fraction of a degree would ruin the entire effect. The builders needed an intimate, long-term knowledge of the sun's changing path across the sky throughout the year. They had to understand where it would rise and set at the solstices, and more importantly, exactly where its light would fall on that specific cliff face at the exact solar noon on those pivotal days. This implies generations of observation. Someone, or more likely a lineage of sky watchers, spent years, perhaps centuries, marking the sun's progress on that butt before ever carving the first spiral or moving the first slab. The sun dagger transforms a cliff into a colossal calendar. For the people of Choco, it likely marked more than just the changing seasons. It signaled times for planting, for harvest, for ceremonies that tied their community to the fundamental cycle of life governed by the sun. It was a sacred confirmation that the cosmic order was intact, a beam of light connecting heaven to earth with a punctuality that has outlasted the civilization that created it. Today, the slabs have shifted slightly due to erosion and human contact, dimming the phenomenon, but its legacy remains a testament to a different kind of genius, one that used the landscape itself as a canvas to capture the unwavering rhythm of the sun. A different kind of map holds a secret far more chilling than any coastline. In 1513, an Ottoman admiral and cartographer named Piri Reis compiled a world map, drawing from sources he claimed included ancient charts captured from Christopher Columbus himself. The resulting artifact is a breathtaking puzzle. It shows the coastlines of Europe, Africa, and the Americas with a curious, sometimes distorted accuracy. But its true controversy lies at the very bottom of the parchment. There, sketched below the Atlantic Ocean, is a landmass that looks unmistakably like the northern coastline of Antarctica. This alone would be remarkable, as Antarctica was not officially discovered until 3 centuries later in 1820. The impossibility deepens. The map does not show Antarctica as a frozen, glacial continent buried under miles of ice. It depicts it with bays, rivers, and what appear to be mountain ranges, a topography consistent with the land beneath the ice, a landscape hidden from human eyes for at least 12,000 years. How could a 16th century admiral know the shape of a continent humanity had not yet found, and portray it not as it was in his time, but as it was in a distant, ice-free past? Piri Reis himself provided a cryptic clue. In notes on the map, he stated he was not the original surveyor, but a compiler. He wrote that he had used source maps dating back to the time of Alexander the Great. charts from the Great Library of Alexandria, and even older mysterious documents. This suggests his work was a copy of a copy, preserving geographical knowledge from a much older, lost civilization. The most provocative theory is that this ancient source civilization possessed advanced seafaring and cartographic skills during the last ice age, when sea levels were lower and Antarctica's coasts were indeed exposed and ice-free. They would have needed not just ships, but a sophisticated understanding of spherical trigonometry to project the curved surface of the Earth onto a flat map, a technique that seems to be present in the Piri Reis map's construction. Mainstream historians offer counter-arguments. They suggest the southern landmass could be a speculative, distorted version of South America, or a lucky guess based on the ancient Greek concept of a great southern land, terra australis, needed to balance the northern continents. They point out inaccuracies in other parts of the map as proof it is not a perfect scientific document. Yet the correlation between the map's outline and modern seismic surveys of Antarctica's subglacial topography is hauntingly close in certain key areas. It is as if the mapmaker had access to a snapshot of the world from an epoch before history began, a time when the geography of our planet was fundamentally different. The Piri Reis map forces a difficult choice. Is it a bizarre coincidence, a product of imaginative guesswork, or is it a fragile, copied relic, a ghost in the parchment, whispering that our maps of human history are missing entire continents of forgotten knowledge? That map's southern mystery suggests a world remembered from a different age. But what if ancient knowledge went beyond geography, reaching into the very fabric of the universe itself? For this, we turn from parchment to poetry, to the ancient hymns of India. The Rig Veda, one of humanity's oldest texts, composed over 3,000 years ago, is a collection of sacred verses praising the gods and the cosmos. It is not a scientific textbook, yet within its poetic layers, a startling numerical secret lay hidden for millennia. In the 14th century, a scholar named Sayana wrote a commentary on the Rig Veda. While explaining a verse from the first book, a hymn to the sun god Surya, he made an astonishing statement. He declared with the precision of a mathematician that sunlight travels 2,202 yojanas in half a nimesha. On the surface, this is just an ancient unit of distance over an ancient unit of time. But when you convert those units using historical interpretations, the result is breathtaking. A yojana is a variable measure but commonly accepted as about 9 miles. A nimesha is a blink of an eye, calculated in the ancient texts as 1/342nd of a second. Do the math. 2,202 yojanas times 9 miles in half of that tiny fraction of a second. The calculation yields a speed of approximately 186,000 miles per second. The modern, scientifically measured speed of light in a vacuum is 186,282 miles per second. The numbers are nearly identical. This is not a vague, poetic metaphor about swiftness. It is a specific quantitative statement. The probability of a 14th century commentator working with 3,000-year-old poetry accidentally landing on this exact figure through random linguistic choice seems vanishingly small. So what are we to make of this? Skeptics argue vigorously that it must be a coincidence, a lucky alignment of archaic units. They point out that the original Vedic verse itself does not explicitly state this calculation. It was Sayana's commentary written centuries later. Perhaps, they suggest, he was engaging in a form of mystical numerology, not empirical science. Yet the context is compelling. The Vedic tradition possessed a profound and sophisticated cosmology. They spoke of vast cycles of time, of a universe that expanded and contracted, and of light as a fundamental cosmic principle. The idea that a lineage of seers and astronomers, the rishis, could have engaged in deep observational science, encoding their findings in symbolic language for preservation, is not out of character for this tradition. The units themselves, the yojana and the nimesha, were standardized and used in other astronomical contexts like calculating planetary motions. This suggests a culture capable of precise measurement. Could Sayana have been transmitting a piece of knowledge from a much older, now lost scientific tradition, one that had somehow quantified the fastest thing in the universe? Whether a miraculous coincidence or a fragment of forgotten physics, this single line from a medieval commentary forces a profound question. How deep did the vision of those ancient sky watchers truly go? Did they seek only to chart the stars, or did they dare to measure the very pulse of creation itself? That measurement of light hints at a cosmic order ancient minds sought to capture. But to see that ambition written across the earth itself, you must travel to the windswept coast of Brittany in France. Here, in the village of Karnak, lies a mystery of staggering scale. Stretching for miles across the landscape are not just a few standing stones, but armies of them. Over 3,000 granite megaliths, some twice the height of a person, arranged in long, precise rows that march across the fields like petrified soldiers frozen in time. This is the Karnak alignment, the largest collection of standing stones on Earth. For centuries, they were dismissed as a chaotic, pagan monument, but chaos is the one thing they are not. When viewed from above, a breathtaking pattern emerges. The stones are not scattered. They are organized into 3 major groups, with each group containing multiple parallel lines that run for hundreds of meters. The rows are not perfectly straight, they curve subtly, and the stones within them decrease in height along the line. This is not random placement, this is deliberate, sophisticated design. And the key to its purpose is written in the sunrise. Certain critical rows within the complex are aligned with breathtaking precision to the rising sun on the solstices and equinoxes. At the summer solstice, the sun would have risen directly over a specific menhir or standing stone at the end of one of the grandest rows, casting a long shadow down the avenue. At the equinoxes, when day and night are equal, the sun would align with another key stone, marking the balance of the year. This transforms the entire, sprawling complex from a collection of rocks into a colossal solar calendar etched into the living earth. The scale of this calendar is almost unimaginable. To use it, you wouldn't stand in one place, you would move through it. A priest or astronomer might begin a ritual walk at one stone at dawn on the winter solstice, following the alignment of shadows and light as the year progressed, culminating at a different stone at the summer solstice peak. The monument itself became a participatory map of the solar year, with different lines and stones acting as markers for different significant days, likely tied to planting, harvest, and sacred ceremonies. This functionality raises a profound question about the builders. Erecting just one of these multi-ton stones would require immense communal effort, careful logistics, and engineering skill. To plan and position over 3,000 of them across miles of terrain with specific astronomical alignments in mind demands a different level of knowledge altogether. It requires a society with a shared, deep understanding of the solar cycle, the ability to survey the land with remarkable accuracy over vast distances, and the long-term organizational power to execute a project that would have taken generations to complete. This was not a weekend project, it was the work of centuries, a sacred contract between a people and their sun, set in stone for eternity. The Karnak stones are a silent testament to a Neolithic world far more organized, more observant, and more intimately connected to the heavens than we often give them credit for. They did not just watch the sky, they built a cathedral to it with the horizon as its altar and the sunrise as its eternal priest. While the stones of Karnak charted the sun's yearly path, another civilization was etching the sky's most dramatic moments into history itself, not on stone but on bone. In the fertile plains of the Yellow River, the kings of China's Shang dynasty ruled over 3,000 years ago. Their world was one of spirits and ancestors, and to communicate with these unseen powers, they developed a profound and systematic ritual. They would carve questions onto the shoulder bones of oxen or the flat undersides of turtle shells. Then, applying intense heat with a bronze rod, they would interpret the resulting network of cracks as divine answers. These oracle bones are the very dawn of Chinese writing, but the questions they asked were not only about harvests or warfare, they were questions for the heavens. Among the thousands of surviving fragments, archaeologists have found chillingly precise records of celestial terror. One inscription from around 1300 BCE reads, "The day was dimmed. Three flames ate the sun, and great stars were seen." This is a clear eyewitness account of a total solar eclipse describing the sun's corona, the three flames, and the sudden appearance of stars in the daytime sky. Another bone asks anxiously, will the moon be eaten? A direct reference to an impending lunar eclipse. Perhaps most astonishing are the records of guest stars, what we now call nova or supernova. One inscription notes the appearance of a new, brilliant star in the constellation we know as Scorpius, a star that shone for months before fading away. These were not casual notes, they were state documents. The Shang king was the chief diviner, and his scribes meticulously archived every crack, every question, and every celestial omen. This reveals a staggering level of bureaucratic organization. They were not just watching the sky, they were logging it, creating a systematic archive of cosmic events and correlating them with earthly affairs. A comet might foretell a military defeat, a solar eclipse the death of a noble. This practice created, over centuries, a vast database. By tracking the cycles of eclipses and the irregular appearances of guest stars, these priest astronomers were doing more than fortune-telling. They were engaged in the earliest form of data science, searching for patterns in the chaos of the cosmos to guide the fate of their kingdom. The oracle bones show us that astronomy in ancient China was not a fringe curiosity. It was a central pillar of state power, a sacred science where the crack of a turtle shell and the vanishing of the sun were part of the same unbreakable cosmic order. From the sacred archives of the Shang, we journey to a landscape where the sky itself was drawn upon the earth. Etched into the arid, stony plains of southern Peru, the Nazca lines are one of archaeology's most enduring enigmas. Most know them as the giant figures, the hummingbird, the spider, the astronaut visible only from high above. But these famous zoomorphic shapes are just a small part of the story. Scattered across hundreds of square miles are thousands of other markings, vast geometric shapes, trapezoids, and most importantly, long, straight lines that stretch for miles across the desert floor, arrows straight and undeterred by hills or valleys. For decades, these lines were seen as ritual pathways or sacred art. Then, a German mathematician named Maria Reich dedicated her life to their study, and she saw something else entirely. She proposed that these lines were not random but deliberate sight lines to the heavens. Through meticulous surveying, Reich and other researchers found that many of the longest, most prominent lines point directly to the rising or setting positions of the sun, the moon, and specific bright stars during the solstices and equinoxes. One major line, for instance, aligns with the winter solstice sunset, while another points to the rising point of the star group we call the Pleiades at a key time of year. This transforms the entire desert plateau into a colossal astronomical calendar, a permanent record of celestial events drawn on a scale so vast it defies ordinary comprehension. The purpose of this calendar was profoundly practical and spiritual. The Nazca culture depended on agriculture in an unforgiving desert environment. Knowing the precise timing of the solstices and equinoxes and tracking the heliacal rising of certain stars would have been critical for predicting the arrival of seasonal fog and the rare, precious rains that allowed their crops to survive. These alignments likely dictated the ceremonial cycle as well, telling priests when to conduct rituals to appease the mountain gods who controlled the water. But the true mystery of the lines is in their perspective. They are virtually invisible from ground level. Walking among them, you see only shallow grooves in the gravel. Their full form, their perfect geometry and alignment only becomes clear from a high vantage point, like a nearby hill or, as many speculate, from the air. This raises a haunting question. If the lines were meant to be used as an astronomical calendar, how did the Nazca people use them? Did they climb the surrounding foothills to watch the sun set along a specific line? Or is there a deeper layer to their design, one that suggests they were created not just for human eyes, but as messages or offerings to the celestial beings they believed watched from above? The Nazca lines are a paradox, a precise, earthly tool for reading the sky, crafted in a form that seems intended for viewers who are not of the earth. They remind us that ancient astronomy was never just about prediction. It was about connection, a desperate and beautiful attempt to inscribe human order onto the vast, untouchable clockwork of the cosmos. This relentless gaze upon the heavens was not unique to the Nazca. Nearly 3,000 years earlier and halfway across the world, another civilization was committing the motions of a planet to a far more permanent medium, clay. In the royal libraries of the Babylonian Empire, amidst tablets detailing everything from grain taxes to epic poetry, we find the Venus tablet of Amasyajuka. This unassuming rectangle of baked clay, inscribed with the precise wedge-shaped marks of cuneiform, is a window into a mind that saw the cosmos as a great book of divine messages. It dates to the mid-second millennium before the Common Era, a record from the reign of King Amasyajuka, but its contents are not about the king's deeds. They are a meticulous year-by-year log of the planet Venus. For 21 years, Babylonian astronomer priests tracked the planet's first appearance as the morning star, its disappearance, its re-emergence as the evening star, and its next vanishing act. They recorded these celestial events with the dry precision of accountants, noting the month and the day according to their own lunar calendar. The purpose of this relentless data collection was intensely practical yet deeply spiritual. In the Babylonian worldview, the gods spoke through natural phenomena. The sudden brightening of Venus was not just a beautiful sight, it was an omen, a direct communication from the goddess Ishtar. The tablet itself is part of a massive 70-tablet series called Enuma Anu Enlil, a kind of celestial reference manual for diviners. A priest would consult it, match a current astronomical event to a recorded one from centuries past, and then read the associated prophecy. Did a specific pattern of Venus's appearances in the 7th year of Amasyajuka's reign precede a great military victory? If that same pattern repeated in the current king's time, it might be seen as a divine endorsement for war. This transforms the tablet from a simple log into something far more profound. It is evidence of systematic, long-term scientific observation in the service of religion. To create reliable omens, you first need reliable data. You need to discern the planet's complex 584-day cycle from the noise of the sky. This required generations of observers passing down their records, comparing notes, and slowly building a predictive model of Venus's behavior. They were searching for patterns in the divine, and in doing so, they accidentally founded the science of planetary astronomy. The Venus tablet stands as one of the earliest known examples of a civilization not just watching the sky, but formally documenting its rhythms over decades, creating a legacy of data so precise that modern astronomers can still use it to study changes in Earth's rotation over the millennia. It is a humble piece of clay that captures the moment humanity began to shift from fearing the capricious will of the stars to understanding they moved to a clockwork beat. The Babylonian scribes saw the sky as a divine ledger, but for another culture, the cosmos was not a book to be read, but a song to be walked. For over 50,000 years, the Aboriginal peoples of Australia have maintained the oldest continuous astronomical tradition on Earth, a knowledge system woven so deeply into life that it blurs the line between land, story, and star. This is the world of the songlines. To call them mere paths is to miss their profound nature. A songline is a living oral map, a sequence of locations, landmarks, and natural features connected by a specific ancestral story that is sung as one travels. Each verse in the song corresponds to a feature in the landscape, guiding travelers across hundreds of miles of desert, mountain, and coast with perfect accuracy. But the true genius of the songlines is that they do not exist solely on the ground. These terrestrial pathways have celestial counterparts mirrored perfectly in the night sky. The same ancestral beings who shaped the rivers and mountains during the Dreamtime also took their place in the heavens. As you walk the song on Earth, you are tracing a constellation in the sky. This creates a dual navigation system of breathtaking sophistication. A traveler could be guided by the song of the land by day and by the position of its starry reflection by night. One of the most profound examples is the celestial emu. In Western constellations, we see a scorpion in the Milky Way, but across much of Australia, the dark dust clouds within our galaxy's bright band are seen as a giant emu in the sky. Its head is formed by the Coalsack Nebula near the Southern Cross, its long neck and body by the dark rifts flowing through the Milky Way. This is not just a picture. The emu's orientation changes throughout the year, and this movement is a precise seasonal calendar. When the emu appears horizontal in the early evening sky, it is said to be running, signaling the time when real emus are laying their eggs. When it appears standing upright, it is the time for egg gathering. This observation ties a specific celestial pattern directly to a crucial ecological and food-gathering event. Their knowledge extended to individual stars with stunning precision. Many groups tell stories of the red giant star Betelgeuse in the constellation we call Orion. Their oral traditions describe it as a variable star, a star that changes in brightness. They recount how it was once bright and young but grew old and dim, and how it will one day brighten again. Modern astronomy confirms this. Betelgeuse is indeed a variable star, pulsing in brightness over a long cycle. For this knowledge to be present in oral traditions, it implies continuous, careful observation of that single point of light for generations, long enough to note its subtle, long-term changes and encode them in story. This is a science of deep time, passed not through writing but through song, ceremony, and art. It represents a holistic understanding of the universe where astronomy is not a separate discipline, but an inseparable thread in the fabric of culture, law, and survival. The songlines remind us that knowledge of the stars can be a living, breathing guide, a way of weaving human life into the very tapestry of the cosmos, season by season, step by step for millennia. Sometimes the most terrifying truths are hidden not in stone or clay, but in story. Among the rich tapestry of Greek mythology, one tale stands out for its sheer cataclysmic imagery. It is the story of Phaethon, the mortal son of the sun god Helios. In the myth, young Phaethon seeks proof of his divine parentage, and his father grants him one wish. Phaethon chooses to drive the sun chariot across the sky for a single day, but he is too weak, too inexperienced to control the fiery steeds. The chariot veers wildly out of its ordained path. It plunges too close to the earth, scorching the continents, boiling the rivers, and burning the skin of entire peoples. It soars too high, freezing the world. To prevent total annihilation, Zeus is forced to strike Phaethon down with a thunderbolt, casting him from the sky. On the surface, this is a classic fable about hubris. But when you strip away the divine characters, you are left with a chillingly specific account of a global disaster, a sky-gone-wrong event that feels less like fantasy and more like a traumatic memory. The details are too precise. The myth describes the earth catching fire, the seas boiling, the very axis of the world shaking. It speaks of Ethiopia's people being burned black, a clear attempt to explain an ethnic trait through a cosmic catastrophe. This is not a simple story of a drought or a bad harvest. This is a description of a world on the brink of incineration from a celestial source. So what could the ancients have been remembering? One compelling theory points to a close passing comet. A massive comet trailing a brilliant, fiery tail and shedding burning debris, streaking terrifyingly close to the atmosphere, would match the description perfectly. The heat radiation, the perception of the sun itself running wild, the global fires, the darkened skies from ash, it all fits. Another theory suggests a massive solar flare, a coronal mass ejection of unimaginable scale, where the sun itself seemed to lash out with a tongue of plasma, disrupting Earth's magnetosphere and bathing the planet in intense radiation and auroral fire. The key is that Phaethon is not the only story of its kind. We find echoes of this celestial terror across the globe. In Hindu mythology, the god Shiva must stop a rampaging celestial fire. Native American traditions speak of a time when the sun moved erratically and the world burned. Egyptian texts reference a heavenly disturbance where the sun god Ra grew weary and rebellious. These are not coincidences, they are fragments of a shared primal fear, a cultural scar from a time when the sky itself seemed to turn against humanity. For ancient astronomer priests, myth was the ultimate storage device. Complex observations of rare, terrifying events that might only occur once every few thousand years, could not be preserved in simple records that might be lost or misunderstood. But a thrilling, moralizing story about a boy who dared to drive the sun chariot, that would be told and retold for generations, its core astronomical truth embedded safely within the drama. The myth of Phaethon, then, may be far more than a warning against pride. It could be a fossilized eyewitness account, a poetic but precise recording of a day when the sun did not behave as it should, a day our ancestors never forgot, ensuring we would remember it too as a shudder in our oldest stories. That fear of a chaotic sky stands in stark contrast to a tradition built on absolute celestial trust. For the Polynesian voyagers, the stars were not omens of disaster, but a fixed and reliable highway painted across the night. With no compass, no sextant, and no maps, they achieved the most audacious feat of exploration in human history, discovering and settling islands scattered across 10 million square miles of open ocean. Their secret was a navigation system so complete it turned the entire Pacific into a familiar neighborhood. At its heart was the star compass, a mental construct of breathtaking elegance. A master navigator or wayfinder did not think in terms of north, south, east, and west. Instead, he divided the 360-degree horizon into 32 houses, each marked by the rising or setting point of a specific bright star. As the Earth turns, stars appear to rise from one point on the eastern horizon, arc across the sky, and set at a fixed point in the west. The Polynesians memorized these precise points for dozens of key stars. The star Sirius, for example, might be the steering mark for one house in the east, and its setting point would mark the corresponding house in the west. To sail toward a known island, the wayfinder would simply keep his canoe aligned so that a chosen guide star continued to rise directly over a specific part of the vessel, or set directly behind it. As that star eventually climbed too high or vanished with the dawn, he would seamlessly switch to another star rising or setting from the same celestial house, maintaining his course through the night. This required holding a mental image of the night sky in constant motion, a living, rotating dome of reference points, but the stars were only one layer of their genius. By day, when the stars vanished, they read the ocean itself. They memorized the complex patterns of swells, the great deep ocean waves generated by distant weather systems. A seasoned navigator could lie in the hull of his canoe and feel, through the vessel's motion, the direction and interaction of multiple swell patterns. These swells acted as a constant rolling compass, their rhythm unchanged even when the wind shifted. They watched the flight paths of birds. Certain seabirds, like the tropic bird, fly out to sea to fish at dawn but return to land at dusk. Spotting one in the evening meant land was within its range, perhaps just over the horizon. They learned to read the sky. A stationary pile of clouds on an otherwise clear horizon often betrays the presence of an island, as its mountains interrupt the flow of air and create cloud cover. Even the color of the water and the types of floating debris gave clues. This was not blind drifting. This was intentional, repeatable exploration. A wayfinder would embark on a voyage with a star path in mind, a sequence of stars to follow, and the confidence that his layered knowledge would get him there. He carried the entire Pacific in his head, the star houses, the swell maps, the bird zones, and the stories of his ancestors who had sailed the same routes before him. When European explorers with their chronometers and charts marveled at finding remote islands already inhabited, they were witnessing the culmination of this ancient science. The Polynesian navigators did not conquer the Pacific by fighting it, but by listening to it, by weaving themselves into its celestial and oceanic rhythms so completely that the greatest expanse of water on Earth became a charted, knowable world. Yet the Polynesian wayfinder's mastery of the present sky pales before a different kind of genius, one that sought to weave multiple cosmic cycles into a single, unbreakable fabric of time. In the jungles of Mesoamerica, the Maya and their cultural ancestors achieved a feat of calendrical engineering that remains one of humanity's most staggering intellectual monuments. They didn't just have one calendar, they had several ticking away simultaneously like interlocking gears in a divine clock, and the heart of this system was the calendar round. To understand its brilliance, you must first grasp its two primary components. The first is the Tzolk'in, the sacred round of 260 days. This wasn't tied to any obvious astronomical cycle like the sun or moon. Instead, it was a combination of 13 numbers and 20-day names which would cycle together, so that each day in the 260-day period had a unique designation like 1 Mix, 2 Ik, 3 Akbal, and so on, until the combination reset after 260 days. The second component was the Hob, the vague year of 365 days. It was divided into 18 months of 20 days each, plus a short, unlucky period of 5 nameless days at the end. Now here is where the mathematical magic happens. These two cycles, the 260-day Tzolk'in and the 365-day Hob, ran concurrently. Think of them as two wheels of different sizes turning side by side. The Tzolk'in wheel has 260 teeth, the Hob wheel has 365 teeth. They start together on a specific day, say 1 Mix 0 Pop. The wheels begin to turn. Because 260 and 365 share no common factors, it takes an immense amount of time for the same combination of a Tzolk'in date and a Hob date to repeat. You have to wait a full 18,980 days, which is exactly 52 Hob years. This 52-year period is the calendar round. For the Maya, this was more than a date-keeping system. It was the very pulse of existence. The completion of a calendar round was a time of profound cosmic danger and renewal. Fires were extinguished, pottery was smashed, and ceremonies were held to ensure the world would continue for another cycle. But what is the origin of that mysterious 260-day sacred round? Its lack of a clear solar or lunar link has puzzled scholars for generations. Several compelling astronomical theories exist. One points to Venus. The planet's average appearance as the morning or evening star is about 263 days, a remarkably close match. Another theory involves the sun. In the Maya latitudes, there are 2 days each year when the sun passes directly overhead at noon, called zenith passages. The interval between these zenith passages varies, but averages about 260 days across the region. A third, more human-centric theory notes that 260 days is remarkably close to the average duration of human gestation, from first missed menstruation to birth, linking the calendar to the cycle of life itself. Perhaps the truth is a fusion of all three, a number that harmonized the rhythms of the planet, the sun, and humanity into a single sacred count. The true achievement, however, is not in any single cycle but in their synthesis. The calendar round was a tool of breathtaking intellectual power. It allowed priest astronomers to track the positions of the sun, moon, and Venus against this fixed grid of sacred time, predicting eclipses and planetary events with precision. Every day in their history carried a unique cosmic signature from multiple cycles. This system was so powerful, so complete, that it became the foundational calendar for all major Mesoamerican cultures, from the Olmec to the Zapotec to the Aztec. It was a shared language of time, a testament to a civilization that saw the universe not as chaos, but as an intricate, predictable dance, and devoted centuries to mapping its every step. The Maya wove time into a sacred fabric, but the Egyptians carved the night itself into a functional clock. Deep within the tombs of pharaohs and nobles, painted across the insides of coffin lids and arched tomb ceilings, are some of the most beautiful and practical star maps ever created. These are the diagonal star tables, and they reveal a system of timekeeping so elegant it divided the darkness into manageable, sacred hours. The system was built upon the decans, 36 small star groups or constellations that rose consecutively on the eastern horizon just before dawn, each spaced about 10 days apart. Over the course of a year, a new decan would make its first brief appearance at sunrise, heralding a new 10-day period, a kind of week in the Egyptian civil calendar. But their true genius was applied to the night. The Egyptians divided the period of total darkness into 12 equal hours. Since the length of night changes with the seasons, these were not fixed hours like ours, but units that stretched and contracted. To track these passing night hours, they used the decans as markers. As night fell, a specific decan would be visible rising in the east. Over the course of the night, that decan would climb across the sky and eventually set. The rising of the next decan in the sequence would mark the passing of another night hour. This required an intimate, memorized knowledge of the star groups and their positions throughout the year. The diagonal star tables found in tombs are essentially cheat sheets for eternity. They are grids with the 36 decans listed in rows. What makes them diagonal is their most clever feature. Each decan is shifted one place to the right in each successive monthly column. This diagonal arrangement accounts for the fact that a star rises about 40 minutes earlier each night. Over a 10-day period, that shift adds up to a full night hour, meaning the star that marked the first hour of night one month would mark the second hour the next. The table allowed a priest or astronomer to quickly look up which decan should be rising at a given hour on any given 10-day period of the year. This was precision engineering for the soul as much as for society. In the Egyptian belief system, the sun god Ra traveled through the 12 regions of the underworld during the 12 hours of night. The decans were not just timekeepers, they were divine companions and guardians for this perilous journey. By knowing the hour via the stars, the living could synchronize their rituals to aid Ra's passage, ensuring he would be reborn at dawn. And for the deceased, whose coffin lid might bear this very table, it served as a guide for their own soul's celestial voyage, a map to navigate the same starry hours toward rebirth. This transforms a practical tool into a profound philosophical statement. For the Egyptians, timekeeping was a sacred act that maintained cosmic order. By measuring the night with stars, they were participating in the eternal cycle that held chaos at bay, linking the rhythm of their rituals directly to the turning gears of the universe. The Egyptian star tables measured the night for gods and kings, but on the vast plains of North America, a different people painted the cosmos to guide an entire way of life. In the possession of the Pawnee people was a sacred object of profound beauty and knowledge, a star chart painted on a buffalo hide. This was not a map of abstract dots and lines. It was a vibrant, living portrait of the sky as they knew it, where constellations were not heroes and monsters, but reflections of their own world, their lodges, and their ceremonies. The hide depicts familiar star patterns, but through a lens that transforms them completely. What we call Corona Borealis, the northern crown, is not a jeweled diadem to the Pawnee. It is the Council of Chiefs, a circle of wise leaders seated in perpetual deliberation. The Big Dipper's bowl becomes a stretcher carrying a sick man, its handle the procession of healers following behind. Each cluster and bright star is an element from their cosmology and their physical landscape. tying the heavens directly to the earth they walked upon. This star chart was far more than decorative art. It was a functional instrument of memory and a sacred ceremonial object. During important rituals, particularly those related to the morning star ceremony, the hide would be unfurled. Elders and priests would use the painted figures as prompts, a mnemonic device to recall the vast oral traditions associated with each star group. The stories encoded in these patterns were not mere folklore, they were dense with practical, life-sustaining knowledge. The position of the Council of Chiefs in the evening sky might signal the time for certain political gatherings or dispute resolutions. The appearance of the stretcher stars might correlate with the season for harvesting particular medicinal plants. The entire celestial panorama served as a calendar, its turning marking the migration of buffalo, the planting of corn, and the cycles of hunting and harvest that meant survival on the plains. This represents a sophisticated, practical astronomy that was utterly seamless with culture. There was no separation between studying the stars and living a spiritual, communal life. To know the stars was to know the stories. To know the stories was to know the duties of the season. And to perform those duties was to fulfill a sacred contract with the universe. The Pawnee did not just observe the sky, they conversed with it, seeing in its patterns the same social structures and natural rhythms that governed their villages. Their star chart collapses the distance between the human and the cosmic, reminding us that ancient knowledge often sought not to explain the heavens as a distant mystery, but to weave them into the very fabric of daily existence, where every rising star had a story to tell and a duty to impart. While the Pawnee saw stories in static stars, Chinese court astronomers were trained to spot the one thing that did not belong. In the early hours of July 4, 1054, a celestial stranger appeared in the constellation of Taurus. To the imperial astronomers of the Song dynasty, this was a guest star, a term for a new, bright point of light where none had been before. Their mandate was clear and bureaucratic: observe, measure, and record everything. And so they did, with a level of detail that would make a modern scientist nod in admiration. They pinpointed its location with remarkable accuracy, noting it was near the star we call Zeta Tauri. They logged its brilliance, stating it was visible in broad daylight for an astonishing 23 days, rivaling the planet Venus. And they tracked its slow fade from view, noting it remained visible to the naked eye in the night sky for a total of 652 days before finally vanishing. This was not a casual observation. It was an official entry in the state annals, part of a continuous tradition of astronomical record-keeping that spanned dynasties. The purpose was practical and political. Celestial omens were believed to reflect the emperor's mandate from heaven. A brilliant guest star could signify great fortune or a coming upheaval, so monitoring it was a matter of state security. This bureaucratic diligence created an unintended gift for the future. That meticulous 10th century record is now one of the most prized documents in astrophysics. Because the guest star of 1054 did not simply vanish. It was a supernova, the catastrophic explosion of a massive star. Today, in that exact spot in Taurus, we find the Crab Nebula, a beautiful, expanding cloud of gas and dust, still hurling material outward at over 3 million miles per hour. At its heart spins a pulsar, the dense, city-sized corpse of that dead star, rotating 30 times per second. The Chinese record provides the exact date and location, allowing modern astronomers to calculate the nebula's expansion backward in time and confirm its origin. It gives us the precise age and behavior of one of the most studied objects in the sky. The contrast with other parts of the world is stark. While the Song court scribes were making daily notes, there is only sparse and ambiguous mention of this world-changing event in European or Islamic records of the time, despite it being easily visible. Some scholars suggest cultural or religious factors in the West may have discouraged the recording of such a potentially disruptive celestial sign. This silence highlights the extraordinary value of China's systematic approach. For over 2 millennia, imperial astronomers maintained what is essentially the longest-running experiment in human history, a continuous watch of the night sky. This archive has allowed modern researchers to identify the remnants of other ancient supernovae, track the behavior of comets, and even study the long-term variability of stars. That single note about a daytime star in 1054 is more than a historical curiosity. It is a data point in a cosmic timeline, a direct link between a scholar's ink brush and the violent death of a star 1,000 years ago. It reminds us that sometimes the most profound scientific legacies are born not from a quest for pure knowledge, but from the simple, disciplined act of watching and writing it all down. Carved into the smooth sandstone of Arizona's Second Mesa, Prophecy Rock is not a simple petroglyph. It is a dense, enigmatic diagram, a cosmic codex etched by the Hopi people that many believe maps the entire journey of humanity. At first glance, you see a central vertical line, a ladder between worlds. On either side, two human-like figures stand, one holding a planting stick, the other a bow. But the true mystery swirls around them. A large, dominant spiral engulfs much of the design, and along that central line are a series of circles, each seemingly representing a distinct phase or world. Traditional Hopi elders explain this as the story of the emergence, a sacred narrative of how their people passed through successive worlds, each ending in a purification due to humanity straying from spiritual harmony before climbing to the present fourth world. The figures represent the two paths available in each age, the path of the peaceful farmer and the path of the warrior, with the spiral symbolizing the migrations and trials the people must endure. Yet when you listen to the deeper interpretations from within the tradition, a staggering astronomical possibility emerges. Some Hopi wisdom keepers and outside researchers suggest the Great Spiral is more than a symbol of a journey on Earth. They propose it is a map of time itself, specifically tracking the precession of the equinoxes. This is the slow, 25,800-year wobble of Earth's axis, which causes the position of the sunrise on the equinox to drift backward through the constellations of the zodiac over millennia. The circles along the central line could then represent not just worlds, but the great ages defined by this celestial clock. The figure with the planting stick would symbolize the age of Taurus the bull, an agricultural era when the spring equinox sun rose in that constellation thousands of years ago. The figure with the bow could point to the subsequent age of Aries the ram, a more warlike period. This interpretation suggests the Hopi cosmological calendar is synchronized with this grandest of all celestial cycles. The implications are profound. To encode precession into a rock carving implies an oral tradition that has preserved precise astronomical observation over timescales that dwarf recorded history. It means watching the stars not for decades but for hundreds of generations, noting the imperceptible creep of the cosmic backdrop against the fixed points of the solstice sun. This knowledge would have been maintained not with written records, but through ceremony, story, and ritual passed down with sacred duty. Prophecy Rock then transforms from a tribal history into a potential monument to deep time. It asks whether the Hopi, through millennia of unwavering watchfulness, achieved an understanding of the cosmos's slowest rhythm and etched a warning and a promise into stone. A reminder that our world, too, is just one circle on a much larger turning spiral. The Hopi Rock speaks of worlds turning in a spiral, but on the other side of the globe, a stone temple complex aligns with a frozen dragon in the sky. Angkor Wat, the magnificent heart of the ancient Khmer Empire, is a masterpiece of spiritual architecture, its soaring towers designed to represent the sacred Mount Meru, home of the gods. Its primary orientation is toward the west, a direction traditionally associated with death and Vishnu, to whom the temple is dedicated. Yet beneath this clear religious symbolism lies a celestial puzzle of staggering scale. In the 1990s, a researcher named John Grigsby proposed a theory that sent shockwaves through both archaeology and astronomy. He suggested that the entire ground plan of Angkor Wat, its 5 iconic central towers and its long causeways, was a precise terrestrial map of the constellation Draco, the dragon, as it would have appeared in the night sky at the spring equinox, not in the 12th century when the temple was built, but in 10,500 years before the Common Era. To test this, he overlaid a star chart of Draco from that ancient date onto an aerial photograph of the temple. The correlation is visually arresting. The main stars of the dragon's winding, serpentine body seem to align with the positions of the temple's major towers and architectural nodes. The star Thuban, which was the pole star in that distant epoch, sits directly over the central sanctuary, the most sacred point of the entire complex. This is not a loose, suggestive fit. It is a specific, detailed overlay that matches the constellation's distinctive coiling shape. If deliberate, this alignment would be an act of architectural time travel, a message cast in sandstone meant to last for millennia. Proponents of the theory argue it points to a first time, a sacred epoch remembered in myth when the gods walked the earth and the heavens were in a different order. By encoding this ancient sky into their temple, the Khmer builders could have been anchoring their kingdom to that primordial moment of creation, claiming a divine lineage that stretched back to the dawn of civilization itself. They would have needed access to an astronomical tradition of unbelievable antiquity, preserving knowledge of precessional shift over 12,000 years, likely through an unbroken oral or written tradition passed down from a lost precursor culture. The mainstream academic response, however, is deeply skeptical. Critics point out that any complex arrangement of points, like a constellation or a temple layout, can be made to match another through selective interpretation. They argue that if you shift the star chart slightly or choose a different epoch, the correlation falls apart. The primary purpose of Angkor Wat is well understood within Hindu and Buddhist cosmology, and its westward orientation has clear ritual significance that needs no additional fantastical explanation. They see the Draco alignment as a classic case of modern pattern recognition, where we project a meaningful design onto a coincidence, finding a dragon in the stones because we are looking for one. Yet the precision of the match and the specific culturally significant date of 10,500 BCE gives one pause. Could it be both? A temple built for contemporary religious practice whose brilliant architects, masters of sacred geometry, also embedded a deeper, older layer of cosmic knowledge as a testament to a timeless truth. Angkor Wat stands as a riddle in plain sight, its stones asking us whether the greatest monuments are built only for their own age, or as vessels to carry a whisper from a time when the dragon circled the pole. The celestial dragons of Angkor Wat speak of cosmic order on a monumental scale, but sometimes profound knowledge is hidden in the smallest, most personal of marks. Carved into the edges of standing stones and the corners of ancient manuscripts across Ireland and Britain, you will find a script of stark, elegant lines. This is Ogham, the alphabet of the Celtic Druids. At first glance, it appears purely practical, a simple cipher of 20 characters, each formed by a series of straight notches or strokes crossing a central stem line. Each character is named for a tree or a plant. The first letter, Beith, is the birch, Lewis is the rowan, Fern the alder. This is the Ogham tree alphabet, a system where literacy is rooted literally in the forest. But to see it only as a writing system is to miss the forest for the trees. Many scholars now believe Ogham was far more than an alphabet. It was a complex mnemonic device that encoded an entire philosophy of time, a living calendar synchronized with the moon and the turning seasons. The structure of Ogham holds the first clue. The alphabet is divided into 4 groups of 5 letters called Epochs. These groups may correspond to the 4 quarters of the year, the great Celtic fire festivals that divided the annual cycle. Samhain on November 1st marked the end of the harvest and the beginning of the dark half of the year. Imbolc in early February welcomed the first lambs and the returning light. Beltane on May 1st celebrated fertility and the peak of spring. Lugnasad in August honored the first harvest. Each festival was a pivot point in the solar year, but the Celts were keen lunar observers as well. Here the theory becomes fascinating. A year contains approximately 13 lunar cycles, 12.37 to be exact. The Ogham alphabet with its 20 characters could have been used to track this. Imagine a 13-month lunar calendar where each month was represented by one of the Ogham letters and therefore by its sacred tree. The remaining 7 letters might have marked the extra days needed to reconcile the lunar year with the solar cycle, or perhaps represented special festival days. In this system, the year would not just be counted, it would be felt. The month of the birch, Beeth, might correspond to the first new moon after the winter solstice, a time of new beginnings and purification. The month of the oak, Jur, whose name shares a root with the word for door, could align with the summer solstice, the doorway into the year's waning half. This creates a seamless weave between the written word, the celestial rhythm, and the ecological reality of the Celtic world. To write a word in Ogham was to invoke the power and essence of specific trees. To track time with it was to place human activity within the sacred, predictable cycles of the moon's growth and the forest's seasonal changes. The Druids who guarded this knowledge were not just priests or poets, they were astronomers and ecologists using this elegant script as a tool to hold all these realms together. The Ogham stones that stand in silent fields today are not merely grave markers or boundary signs. They are perhaps frozen almanacs, their inscriptions whispering of a time when to know your alphabet was to know the exact phase of the moon, the sacred tree in power, and your own place within the endless turning wheel of the natural world. The Druids tracked time through trees, but a living tradition in West Africa points its knowledge at a single, specific star. Among the cliffs of Molly's Bandiagara escarpment, the Dogon people have preserved a cosmology of breathtaking specificity. For generations, their priests have spoken of a tiny, incredibly heavy companion star to Sirius, the brightest star in our sky. They call this companion Potolo, the seed star. Their oral traditions describe it as made of a metal heavier than all the iron on Earth, and state that it orbits Sirius in an elliptical path, completing one revolution every 50 years. This is not a vague myth. It is a precise astronomical description of Sirius B, a white dwarf star that was only confirmed by Western astronomers in the 19th century with powerful telescopes. Sirius B is utterly invisible to the naked eye. It is 10,000 times dimmer than its brilliant partner, Sirius A, and orbits it in a 50.1-year cycle. It is also one of the densest objects known. A teaspoon of its material would weigh many tons. The Dogon knew all of this. The question is, how? The controversy erupted in the 1930s when French anthropologists Marcel Grioul and Germain Dieterlen lived with the Dogon for years, earning their trust. The priests shared their most secret knowledge, including intricate sand drawings that mapped the orbits of Sirius and its invisible companion. The anthropologists were stunned. They published their findings, suggesting the Dogon's knowledge was ancient, passed down from a time before memory. This ignited a firestorm. One theory, popularized by author Robert Temple, proposed that the Dogon inherited this knowledge from visitors from the Sirius system thousands of years ago, an idea that captured the public imagination but is dismissed by mainstream scientists as pure speculation with no archaeological evidence. A more grounded, yet still radical, suggestion is that the Dogon or a precursor civilization might have developed a form of ancient telescope, perhaps using polished crystals or long, tubular sighting devices to somehow glimpse the faint companion. While intriguing, there is no physical evidence of such technology in the region. The most accepted explanation among skeptics is cultural contamination. They argue that by the 1930s, Sirius B was common knowledge in Western astronomy books and popular science articles. European missionaries, traders, or soldiers passing through the region could have spoken of the amazing discovery of a dark companion to the brightest star, and that story was then absorbed into Dogon mythology, presented to the anthropologists as ancient lore. Proponents of the Dogon's independent knowledge counter this fiercely. They point out that the Dogon describe not just one, but a third star in the Sirius system, a claim that has fueled speculation for decades. More importantly, they argue that the knowledge is woven into the very fabric of Dogon rituals, calendar systems, and artifact designs, like the famous masks used in the Sigui ceremony, which is held every 60 years, a period linked to the orbital cycles of the stars. This depth of integration, they say, feels organic, not like a recent addition. The debate remains at an impasse, a perfect storm of mystery. It forces us to confront the limits of our historical models. Is it more likely that a profound astronomical truth was independently discovered and preserved in oral tradition for centuries, or that it was a fascinating piece of modern science that found a home in an ancient culture, becoming sacred over a few short generations? The Dogon mystery does not give us easy answers. Instead, it holds up a mirror, asking us how we value different kinds of knowledge and what we are willing to believe about the patience and perception of those who came before us. The final case is not a single object or monument, but a constellation woven into the very soul of humanity. Across every inhabited continent, in cultures separated by vast oceans and millennia, the same tiny cluster of stars holds a place of sacred prominence. The Pleiades, that shimmering knot of 6 or 7 visible stars in Taurus, is far more than a celestial curiosity. It is a global clock, a divine symbol, and a profound mystery of shared human experience. In Greek mythology, they are the 7 daughters of Atlas, transformed into stars to escape the hunter Orion. In Japan, they are Subaru, a name now borne by an automobile whose logo mirrors the star cluster. To the Maori of New Zealand, they are Matariki, whose rising heralds the new year and is a time of remembrance, celebration, and planting. Among the Native American tribes of the Great Plains, the cluster is often seen as 7 maidens or a group of children, and its disappearance and return mark the cycle of the agricultural year. This is not a coincidence of naming, it is a convergence of function. From the Andes to the outback, from the Siberian steppe to the African savanna, ancient peoples did something remarkably specific. They timed the most crucial event of their survival, the planting of crops, by the heliacal rising of the Pleiades. This is the moment when the cluster, after being invisible for a period, first reappears in the pre-dawn sky, just before the sun washes the stars away. In the Mediterranean, this event signaled the start of the sailing season for the Greeks. For the Maya, it marked the beginning of the rainy season and the time to plant maize. For the ancient Egyptians, its rising coincided with the annual flooding of the Nile, the lifeblood of their civilization. For countless indigenous cultures, it was the signal to sow seeds, ensuring they would germinate with the coming rains. The practical astronomy here is impeccable. The heliacal rising of a star group is a reliable, seasonal marker, more stable than a lunar calendar and more precise than observing the sun's shifting position alone. But the uniformity is staggering. Why this particular cluster? It is not the brightest object in the sky. Sirius is far more brilliant, Orion is more striking. Yet it was the Pleiades that captured humanity's collective gaze and was entrusted with the sacred duty of marking time. One possibility is that this knowledge stems from a single, ancient source, a primordial civilization of sky watchers whose understanding of this celestial signal spread across the globe with migrating peoples, adapting to local myths but retaining its core function. Another, perhaps more profound, explanation lies in archetypal human psychology. The Pleiades, with its tight, delicate grouping, appears as a small, familial unit, sisters, children, a flock, making it narratively compelling. Its visual distinctiveness, a faint smudge that resolves into pinpoint stars upon closer look, invites story and observation. Its position in the sky makes it a perfect seasonal marker for the Northern Hemisphere's agricultural cycle, a fact independently discovered by cultures who simply looked up with the same need to survive. This global chorus points to something fundamental. It suggests that our ancestors, in their separate cradles of civilization, were engaged in the same great project, reading the same page in the cosmic book. They looked past the wandering planets and the glaring sun to find a humble, clustered clock in the deep dark. The universal myth of the Pleiades may be the strongest evidence that the drive to understand the heavens is not a cultural innovation but a human instinct. In those 7 faint stars, we see not just a tool for planting, but the shared roots of wonder itself, a reminder that every culture, in its own way, once began its year by looking for the same light in the morning sky. These 25 scattered mysteries begin to form a single, startling picture. When you step back from the individual stones, maps, and myths, a set of powerful, recurring patterns emerges, binding these ancient witnesses together across continents and millennia. The first and most profound thread is the universal human compulsion to measure time. This was not a passive hobby, but a desperate, practical need for survival. From the nebulous sky disk harmonizing sun and moon for planting, to the Maya weaving sacred and solar years into a 52-year calendar round, to the Pawnee reading the celestial emu's posture to know when to gather eggs, ancient astronomy was first and foremost a tool for living in rhythm with an unpredictable world. They sought to impose order on chaos by finding the clockwork in the cosmos, turning the terrifying randomness of seasons and weather into a predictable, sacred schedule. This leads directly to the second pattern, the deep, inseparable integration of sky and story. Astronomical knowledge was rarely stored in dry technical manuals. It was encoded in the very fabric of culture, preserved in the vessels most likely to survive, myth and ritual. The terrifying close pass of a comet becomes the story of Phaethon's doomed sun chariot. The precession of the equinoxes is etched into the spiral of Hopi prophecy rock. The complex orbit of Sirius B is woven into the 60-year ceremony cycles of the Dogon. Myth was the ancient hard drive, a narrative format that could carry precise data across hundreds of generations with far more resilience than a clay tablet or a parchment map. The sky was not just observed, it was narrated, and in that narration, its lessons were made eternal. To create those myths required the third unifying trait, a scale of patience that defies our modern imagination. This was not short-term observation. It was a generational project. The builders of Stonehenge encoded an 18.6-year lunar standstill cycle, a pattern one might only witness twice in a lifetime. The Chinese court astronomers maintained a continuous watch of the heavens for over 2,000 years, logging supernova and comets as matters of state. The Polynesian star compass was not invented by a single genius, but refined over countless voyages, each wayfinder adding to a collective memory of swells and star paths that turned an ocean into a highway. This represents a different relationship with knowledge itself, one built on slow accumulation and faithful transmission, where the individual served as a link in a chain stretching into a deep past and a far future. And this brings us to the final, most challenging pattern, the recurring intellectual leap. Time and again, we encounter artifacts and achievements that seem to jump ahead of the assumed technological timeline. The Antikythera Mechanism, with its differential gears and eclipse predictions, appears in a world we thought knew only simple machines. The precision of the Great Pyramid's cardinal alignment rivals modern surveying. The mathematical astronomy in the Venus tablet or the Dresden Codex displays a computational sophistication we did not attribute to those eras. This pattern forces a difficult but essential question. Have we consistently underestimated the ingenuity of past cultures, perhaps because we privilege written records over oral tradition, or monumental architecture over perishable tools? Or do these leaps hint at pockets of advanced knowledge that were gained, concentrated in priestly or artisan classes, and then tragically lost, leaving only ghostly fragments like the gear in the shipwreck or the number in the hymn? Together, these patterns do more than connect dots on a map of mystery. They build a coherent argument for a fundamental re-evaluation of ancient intellectual history. They suggest that the drive to understand the cosmos is a defining human trait as old as culture itself. They show that our ancestors were not primitive stargazers awed by random lights, but diligent scientists and engineers who used the only laboratory they had, the night sky, to build systems of astonishing precision and beauty. The real puzzle may not be how they knew what they knew, but why we ever assumed they couldn't. So this is the portrait that emerges from 25 scattered pieces of evidence. It is not a portrait of primitive people groping in the dark, but of sophisticated cultures who looked up and saw a system. They saw a clock, a calendar, a compass, and a storybook, all written in light. They dedicated lifetimes and the lifetimes of their children to reading it. They built monuments as textbooks and wove data into myths to ensure it would never be lost. The collective picture these cases paint is one of a humanity fundamentally engaged with the cosmos, not as distant worshippers but as intimate students of its rhythms. This legacy should fill us with a profound sense of humility. We stand on the shoulders of giants who measured the universe with nothing but sticks, stones, and patient observation. Our modern telescopes and satellites extend a gaze they began, solving mysteries they first dared to name. Their work reminds us that genius is not defined by the tools available, but by the questions asked and the relentless pursuit of their answers. So the next time you look up at the night sky, remember you are participating in the oldest human tradition of all. You are following the same star paths as Polynesian navigators, marking the same solstice as the builders of Karnak, and wondering at the same Pleiades cluster that told farmers across the ancient world when to plant. The heavens are our shared inheritance, a story written in a language every culture has tried to learn. Perhaps the greatest mystery isn't what they knew, but why we ever forgot. Which of these 25 cases resonated most with you? Was it the ticking bronze computer of the Antikythera Mechanism, or the silent stone calendar of the sun dagger? Let us know in the comments below. If you enjoyed this journey into historical mystery, subscribe for more explorations into the forgotten corners of our past. And tonight, if you get the chance, step outside, look up, see if you can find just one of those ancient markers, and for a moment, see the sky through the eyes of those who came before. You might be surprised by what you remember.